Okay, class. So first of all, I want to show you the answers for the worksheet that we've done. I think it was 2 weeks ago um, about chemical separation. Here's now another student. It's Sarah. That would be number 8 guide. Okay. So I want to show you the marks, or I want to show you the answers for the worksheets, because I know some students did not do it. But I see now I have EQ number 2. I didn't see his worksheet, but now I do see it. He sent me the message. So he is okay, actually. So I want to give you the answers because I think some students did not do it. So let me show you. Yeah, this is my grading sheet. Let's see. On the computer. One moment. There we go. Okay. Okay, EQ number 2 did do it. Teacher didn't mark it yet, but actually number 2, yes, he did it. Number 18 is here, coffee. Some other students did not finish the worksheet. I see all these last ones, you all finish it. Noble finish it. Namu finish it. Popcorn finish it. And EQ also finish it. I just have to check it. But some other students did not finish it. Now today teacher will show you the answers, and I hope this will help you so you can finish it. Okay, because maybe some students, they don't know how to do it, which is okay. I mean, it's not very easy. So if you didn't know how to do it, that's okay. Okay, so I will show you the answers. And then if you did not finish it, you can do it. Okay, let's see. Okay, so class, I'm going to show you the answers of all the worksheets. But please just look at the one that you have to do, because every student have to do one worksheet with your name. And if I have that one, just look carefully, you can finish it. Okay, and some students, they already finish it, so they are okay. If you already do it, it's fine, you are okay. Okay, so let's see. So the first one, this is how to separate magnetic coins and sand. So in question 1, I say, name the components of the mixture. And actually normally I write it at the top. It's sand and coins. Then the type of mixture, heterogeneous, because it's more than one color, so it's heterogeneous. What is the method? The method is to use a magnet. What is the properties of the things in the mixture? So the properties is that nickel coins are magnetic, but sand is not magnetic. So the sand does not stick to a magnet and nickel does. What do you need? You just need a magnet and you need a cup or bowl. And then the process is just take the magnet, drag it through the sand, pick up the coins, take off the coins of your hand, and put them into a bowl. Okay, so this was the first one. Now let's do the next one, acetone. So let's see who was the student who had to do acetone. Let me have a look. P6 Science, all names. Okay, so it looks like it's Jarn, which is number 5, and number 15, and number 19. So 5, 15, and 19 is the students that had to do acetone. Okay, teacher will show you the answer now. Okay, so what is in the mixture? Class, you can tell me, what is in the mixture?
acetone and water.
That's it, acetone and water, and these are both liquids. And actually, acetone is water soluble. So that's why the mixture is homogeneous. So I can see only one color. I cannot see two colors. I just see one color. So it's homogeneous. And then class, the only way to separate this one is distillation. If you try evaporation, maybe it's okay. Maybe you can try evaporation, but distillation is the best method to use for this. So it's two liquids. And then what is the properties of acetone and the property of water? And the only thing is different is the boiling points. Because acetone can boil more easily, something like 80 degrees Celsius. And water has a higher boiling point, which is about 100 degrees Celsius. And then what is the tools? So in your book, you can see the glass things that you need for distillation. It's a special glass apparatus that you need for distillation. Okay, so if you say evaporation is also okay, but actually the best answer is distillation. Okay, let's see, next one. We've got beans. Okay, so let's see who's done this one. And this one is quite easy. I think the students did pretty well with this one. So we have number 6 had beans, number 8 had beans. Student number 17, Nobel, also had beans. And Fasai also had beans. Okay, this one actually wasn't very hard. Maybe I can ask Fiu. Fiu, are you here? So you've done this one, so you can tell the class. So what is in the mixture? So what are the things in the mixture? What is this?
I didn't do this.
Oh, I thought you did. Am I wrong? It says here Fasai beans. No, wait, sorry, you have Fiu. You've done gravel. Is Fasai here? Fasai? Number 24?
Yes.
Ah, there you are. Okay, you've done this one. Okay. So what is in the mixture?
Beans and peppers.
That's good, yes. Heterogeneous or homogeneous?
Heterogeneous.
Yes, because you can see at least two colors. What method do you use?
Hand picking.
That's right. And what is the properties of the beans and the pebbles? So how are they different?
The texture and the color.
Yes, and also the size. Looks like the beans are a little bit bigger than the pebbles, but you can feel there's a difference because the beans are smooth, the pebbles are more coarse. Okay, and then what do you need to separate them?
Hands and cup.
That's it. Hands and cup. That's it. Hands and cup, or you can also say bowl is also fine. Okay, and then the process is quite easy. It just means that you can just shake them a little bit and then just take out all the pebbles because the pebbles are gray and the pebbles feel different from the beans. And then shake it and just take out more. Okay, so that's it for hand picking. And let's see what's the next one. We have brown sugar. Okay, now I think some students didn't know how to do this one, so I can help you. So first of all, what is the components of the mixture? This is something which I always write on the worksheet. So actually it's not hard to find it. It's here at the top. And it says the components is brown sugar and water. Okay. And then let's see who's had the brown sugar and water actually. Let's see. So we had EQ is number 2. You actually finish it. So EQ is okay. And it's only him. Wow. It's only EQ. Okay. And so then let's see which method did he say. He said, I want to see quickly. He said liquefaction. Okay, so that's not quite right. Okay, so the method that you use for the brown sugar, I think, is evaporation. The same if you have sugar, if you have salt, and if you have brown sugar, you can use evaporation. It's the best way. And the reason is that the brown sugar can go into a solution. So brown sugar, it can dissolve in water. That's why if you look at the solution, it's only one color. So you cannot use a sieve. You cannot use filtering. You cannot use sedimentation. The only way to do this is evaporation. Okay, so the properties of brown sugar, it's soluble in water, but it does not evaporate. So when you make the water hot, it's gonna evaporate. But the brown sugar, no, it does not evaporate. It will stay in the pot. So that's the property of the brown sugar. And what tools do you need? You just need a pot, kitchen pot, or you need a saucepan. And you also need a stove to make it hot. Okay, so brown sugar, you have to use evaporation. Okay, next one. Let's see, what else do we have? Coffee. Okay, let's see who's had coffee. So tea had coffee, and coffee had coffee. Student coffee, who's this? This is student 18, also had coffee. Okay, class, so coffee, coffee is funny, you know, because when you make the beans, when you crush the beans, when you ground the beans into powder, some of the coffee will dissolve in the water. And some of it will just be the beans, which is solid, like little powder or little pieces. So if you want to separate them, actually you can use two ways. You can use filtration or sieving. So that plunger that we see here actually has a sieve, but if you put it through the paper, that is called filtration. And so you can use two methods here, filtration or sieving. Okay, the mix is heterogeneous because we will see little pieces of coffee in the liquid. Okay, properties of the coffee bean. The little pieces of coffee does not dissolve in the water. But there's also the liquid part which does dissolve. So some of it does dissolve. If you have the sieve, if you have filter paper, you can separate it. You can take out the pieces of coffee bean or the powder of coffee bean, which is a solid. So normally if you have filtration, it's if you want to separate a solid and a liquid. And what do you need? You can use a funnel and filter paper, or you can use this thing. It's called a coffee plunger. You can also use a sieve. Okay, so you can use either a sieve or you can use filter paper. Okay, so that's coffee. Next one. Coins. Ah, no, this is, we already do this one. Finish coins. Never mind. Next one, flour. Okay, I think some students didn't understand how to do this one. So let's see, who had flour? Nick had flour. Namu had flour. And Pui also had flour. Okay. So this is the flour you use to make bread. It's a powder. It's almost like sand, but it's not hard. It's more soft than sand. And actually, it cannot dissolve in water. So it's not water soluble. And so there's two ways you can separate it. You can use filtration or sedimentation. You can't really say sieving because the pots are too small. So you cannot use sieving. But filtration is okay. But 19 is, yeah. Okay. So the flour, it does not dissolve in water. So if you wait, it will settle down. And all the flour will be at the bottom. Then you can throw off the water. So that's called sedimentation. Okay, so that is the properties of the flour, is that it is not soluble. And it is a solid. It's very small, but it is a solid. So you have to use filtration. Okay, and what do you need? You just need another bowl. And you can also, actually you can't really use a sieve. I think if you use a sieve, it will not work. So that I can take out. No sieve, no sieve. Yeah. Okay. Okay, so class, who of you had this one with flour? Let's see, Pui, Nick, and Namu. Do you understand it now? Do you have questions? Poe, are you there? Number 11. And Nick, are you there? I think Nick is not here. Okay, so for those students, this is the answer. So you can do this one. Okay, next one. Let's see, gravel. Okay, and so few did this one, I think. Let me check. Yeah, few did gravel. Few, can you talk about this one, please?
Yes.
Okay, so what are the components?
Gravel mixed with sand.
That's right. Is it heterogeneous or homogeneous?
Heterogeneous.
That's right. We can see more than one color. How do you separate it?
Sieving.
Sieving, yes. I think sieving is the only way you can do. And what is the difference in properties between the sand and the gravel?
The color.
Color is different, yes. And?
Size.
Size, yeah. I think size is the most important thing because if you use a sieve, it has small little holes. The gravel does not go through the holes. Okay, that's it. And so you just need to use a sieve or a screen. It's also called screen. It's a kind of sieve. And you can separate the mixture. And maybe you just need another container to put the sand, and the gravel will stay in the sieve. Okay, so that's gravel. So the only thing you can do is sieving. It's the only way to separate it. Okay, mothballs. Okay, I'm sure the students could not do this one maybe. Maybe someone can do it. So let's see. Carrot, you had mothballs. Baitong, you also had mothballs. Could you do it? Was it okay? That number 19. No, 19 had acetone. Carrot, are you here? Doesn't seem like it. Okay, anyway. The student number 20, Baitong, and caret is student number 12, is the students that had mothballs. Okay, so let's talk about mothballs. So this stuff is called naphthalene. Naphthalene is white. You can make it like a powder. It almost looks like cake flour, but if you smell it, it has a very bad smell, very strong smell. And if you mix it with sand, it's very hard to separate it. You can't use a sieve. You can't do filtering. There's only one way you can do, which is sublimation. Sublimation, it means that sometimes something solid will turn into a gas, and naphthalene do that. So if you put it on the fire, if you make it hot, naphthalene turn into the gas. That's how you can separate it. Okay, sand doesn't turn into the gas. You can make it really, really, really hot. Maybe if you make it very, 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 very hot, it will become glass. It will be a liquid, but it will never become a gas. Okay. So naphthalene becomes a gas. It's called sublimation. And then you just have a funnel and some cotton wool, and all the gas will go up, 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 and then it will make the powder or the solid, and you can separate it. Okay, let's see, next one. We have peas. Okay, let's see, who had peas? Alice had peas, Dada had peas, and Popgun. Okay, let's see if I have some scores for them. So we have 4, 13, and 16. 4, 13, and 16. 4, yes, 4 have a score. 13 not finished, and 16 not finished. Okay, but it looks like Popgun finished it. Good. Okay, so how do we separate peas? So I think there are 2 ways you can do it. Actually, maybe there are 3 ways you can do it. You can use evaporation. So if you boil the water will go away. You can use decantation to just slowly, slowly, slowly pour the water. Or you can also use sieving, because we know the peas are quite big. So you can have a sieve and you can separate the peas and the water. Okay, so the mixture is heterogeneous. I can see more than one color. And the properties are peas is a large solid and water is a liquid. Peas does not evaporate. Yeah, and then you can also, peas are big solid particles. Okay, what do you need? You just need a stove, you need a saucepan, and maybe a colander, because a colander is like a sieve. Okay, so if you have peas, that's the answer. Let's see, what's the last one? Last one, no, we finished. Okay, class, so some of the students couldn't finish, so please, you have to finish your worksheet. I can still give you a little bit of time. I think maybe this was quite hard, but now I've given you the answers. So I hope this helped you. Okay, class, and so then we are finished with that chapter. So we've spent a lot of time on that chapter, which was the separation of materials, but now we are finished. Okay, so that was page after the magnets. Wait a second, that was separating mixtures was unit 5. Yeah, unit 5, 5.1. Okay, that's interesting. So the whole unit, we finished unit 5, it's finished. Now we do unit 6. Okay, and unit 6 is very interesting. Unit 6 is about rocks. Okay, and today we're just going to watch a video, and then I want you to make a little summary for today. So first we can watch the video. Okay, so let me just switch off the aircon. Okay, so let's watch a video about rocks. So it's here.
Rocks.
Okay, let me ask, class, are you there? Hello?
Yes.
Okay, so I will show you a video about rocks. Let me just get it open. Because this is the new chapter that we are doing. And today we're just looking at the 3 different types of rocks. Yeah? Can you see it? Do you see the orange screen?
Yes, I see.
Yes.
Good. Okay, so please listen to the video about rocks. It's about 8 minutes. And maybe we can watch it twice, but let's just watch the video. Okay, 3, 2, 1, go.
Rocks, and more rocks. Let's take a look at the 3 main types of rocks. Igneous rocks, which are born of fire. Sedimentary rocks, which many come from sediments called clasts. And metamorphic rocks, which come from heat and pressure, kind of like the weight of the world pressing down on you. So up first will be igneous rocks, derived from a Greek word for fire. Igneous rocks form from hot molten rock that cools and then solidifies. Igneous rocks may form from magma, which is found inside the earth, or lava, which is molten rock on the surface of the earth. There are 2 major types of igneous rocks: intrusive and extrusive. Let's take a look at how intrusive and extrusive rocks differ in terms of what they form from, where they are created, the rate of cooling, the size of crystals, and the texture. Extrusive igneous rocks are created from lava. Lava is molten rock found on the surface. Intrusive rocks are created from magma, which is molten rock found inside the earth. Extrusive rocks are created on the surface where molten rock has floated. Intrusive rocks are created inside the earth from hot magma. Extrusive rocks cool quickly. Intrusive rocks cool slowly. They're inside the earth, which acts a little bit like an oven, which slows the rate of cooling. Extrusive rocks may have really small crystals smaller than 1 millimeter, or no crystals at all. Sometimes they may even be vesicular, which means the rock may have air bubbles. Intrusive rocks have crystals larger than 1 millimeter. Take a look at these intrusive rocks and their crystals. Extrusive rocks have a very fine texture. Some, like obsidian, may even be smooth. Intrusive rocks have a coarse texture, which can be described as rough. Because intrusive rocks have larger crystals, this makes their texture rough. See if you can tell if the following rocks are extrusive or intrusive. Another way that you can classify igneous rocks is to determine if the rock is mafic or felsic. Classifying as mafic or felsic is actually a scale of the percent of silica found in the rock. 0 to 45% is considered mafic, and 65% or greater of silica is felsic. 45 to 65% is considered intermediate. Mafic rocks are dark in color, and felsic rocks are lighter in color. The names give you a clue as to what other minerals make up these rocks. Mafic can be broken down into Ma for magnesium, and then Fic, which is Latin for iron. Felsic can be broken down into Fel for feldspar, and Sic for silica. Let's take a look at some mafic and felsic igneous rocks. Let's take a look at metamorphic rocks. This classic building contains a metamorphic rock called marble. Rocks are classified by how they are formed. Metamorphic rocks come from existing rocks that are subjected to extreme heat and pressure. Metamorphic rocks are created when extreme heat and pressure changes the original rock into a new type of rock. Sedimentary, metamorphic, and even igneous rocks can all become new metamorphic rocks when exposed to heat and pressure. The original rock is referred to as the protolith, but it's commonly referred to as the parent rock. Contact metamorphism occurs when existing rock comes into contact with extreme heat, like magma found inside the earth. Kind of like when this toast is exposed to heat inside the toaster and is changed. Regional metamorphism is caused by extreme pressure. The pressure presses and squeezes the rock and transforms it into something new. Kind of like this gravity acts on the balloon and transforms its shape. This often occurs at convergent plate boundaries. Existing rocks are transferred into new rock at these boundaries. Two major types of metamorphic rocks are foliated rocks, which have layers or bands, and non-foliated rocks, which do not have these layers or bands. Here's a common example of metamorphic rocks. Shale morphs into slate, which morphs into phyllite, which transfers into schist that can morph into gneiss. Another common example, sandstone, when exposed to heat or pressure, morphs into quartzite. And this limestone will morph into marble. Now let's take a look at sedimentary rocks. This rock wall is an example of sedimentary rock. Sedimentary rocks are derived from igneous, sedimentary, and metamorphic rocks. Sedimentary rocks make up around 75% of the rocks on the Earth's surface. Let's take a look at how clastic sedimentary rocks form. Clastic sedimentary rocks are the group of rocks most people think of when they hear the term sedimentary rocks. Clastic sedimentary rocks are made up of pieces of pre-existing rocks called clasts that vary in size. These sedimentary rocks follow WED-CC in order to form, which stands for weathering, erosion, deposition, compaction, and cementation. Weathering is when
number 19, yes? Oh, you just want to say that you're here?
I have a problem.
Oh. You cannot see the video? Maybe I will just rewind the video. Can you see now? Okay, so I rewind the video. Let's just watch again the last little bit again. Okay, 1, 2, 3.
Tree rocks make up around 75% of the rocks on the Earth's surface. Let's take a look at how clastic sedimentary rocks form. Clastic sedimentary rocks are the group of rocks most people think of when they hear the term sedimentary rocks. Clastic sedimentary rocks are made up of pieces of pre-existing rocks called clasts that vary in size. These sedimentary rocks follow WED-CC in order to form, which stands for weathering, erosion, deposition, compaction, and cementation. Weathering is when pre-existing rocks are broken down. This may occur by freezing and thawing of water inside the cracks of rocks, trees and other plants growing into cracks, and even blowing winds. Next, you have erosion, which occurs when these clasts or pieces of rocks are created during weathering and then are transported by either wind, water, or even gravity to a new location. Deposition is when the particles are deposited as loose sediment. Usually this is near a body of water, but not always. Over time, compaction occurs as layers of deposition build on top of one another and begin to squeeze together. Cementation occurs eventually when the minerals in the water will act like glue and cement all the pieces together. The end result is a sedimentary rock. This process of loose sediment hardening into rock by cementation and compaction collectively is called lithification. Math uploads a math and science video every day.
That's
Please
it.
subscribe and share.
Okay, let me just switch on the air conditioning. Okay.
Okay, class, so the video is a little bit difficult. I think there's some of the things in the video, maybe you don't have to know it. But I think all the things that is in your textbook is also in the video. And the pictures does help to explain some of the things. So if you want to watch the video, I can put it on your group. Let me see, group 6. But there are better places to find information on websites also, which is what you'll be doing later today, actually. But first, we can just look at the book, and maybe I can just sort of give you an overview of the 3 kinds of rocks. Okay, so let's stop this one. Okay, and let's open the book pages, which is P6. Oh, here we go. P6 book. Okay. Okay, let's see. This is page about 155. About here. Here we go. Okay. So, class, there are mainly 3 kinds of rocks. And so from the video, I can tell you that the 3 kinds of rocks, we have igneous. Igneous, it means it comes from a volcano or magma. Because, you know, inside the earth, it's very hot. And inside the earth, the rocks can be a liquid. So that's something like about 2000 degrees Celsius. It's like very, 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 very hot. And then the rock can be a liquid. And that is how many rocks are formed. Now sometimes if the volcano goes out onto the surface of the earth, we can have rocks. That one is called extrusive rocks. Okay. And sometimes there are rocks which is inside, it doesn't go outside. That is called intrusive rocks. but they're both igneous and they both come from magma or volcano. Then we have sedimentary rocks. So sedimentary rocks is just layers of rocks, many layers. And then because of the weight, just presses down on it and it makes it more dense, or it compacts the rocks. Okay, so that is sedimentary rocks. And something like sandstone, I think, is an example of a sedimentary rock. And the last one we have, metamorphic rocks. The word metamorphosis, it's like when a butterfly, well, when a locust or a pupa turns into a butterfly. It's like a little worm, and the worm goes into a cocoon, and it comes out and turns into a butterfly. That is the word metamorphosis. It means when you change into something else. That is metamorphose. So metamorphic rocks is when the sedimentary rocks or the igneous rocks are changed. And normally it happens with heat and pressure. In the video you could see the first picture, like when the earth pressed down on something and it's also very hot, the rocks will change into something else. So that is metamorphic rocks. So actually there are only 3 types of rocks. So let's just look at the book. Okay, so it says here, okay, so you can find many rocks on the Earth's surface. Rocks are very hard. They always have a fixed shape and a fixed volume. They can have some different things in them, like some minerals or some kind of chemical compounds inside the rock. And some is also useful for us. Okay, we can do this later. Well, actually, we can do it later. Okay, and then the experiment, actually, it's not really an experiment. This is something where you have to find information, which is actually what you're going to do today. But first, I just want to have a look at all the rocks before we do that. Okay, so rock can be formed from more than one kind of mineral. So mineral is what the rocks are made of. A mineral is a crystal. It's some kind of chemical compound, like silicon or iron or magnesium, or another metal, or carbon, or any kind of chemical element. That is a mineral. And a mineral is the thing that will make the rock. And we know the earth has a lot of iron, the earth has a lot of silicon, the earth has magnesium, the earth has all these minerals, nitrogen, and so on. And they form the rocks. Okay, this, I don't want to show you this. Come on, computer. Okay. Okay, so they are igneous, sedimentary, and metamorphic rocks. There are only 3 kinds of rocks. And so in your book, you can find information. So igneous rocks, there are 2 kinds. The ones that are, in the magma is intrusive. And the ones that are in the volcano is extrusive. Okay, so the one inside the earth is intrusive. And the one outside the earth is extrusive. Okay, so that is the magma, and here is some examples about intrusive rocks. You can see the color, you can see the coarseness, you can see the roughness and so on of these rocks. And here's some extrusive ones. I like this one. This one is like black glass. I quite like this one. It's called obsidian. Okay, then we have sedimentary ones. So sedimentary ones is just like a lot of layers, and then because of the pressure, it becomes a rock. So let me see. It's too bad they don't have a very big, very nice diagram about this, but it's just a lot of layers. If you put a lot of types of rocks on each other, the pressure will create some kind of stone. Sandstone is a very famous example. And the last one, metamorphic, it just means any kind of rock will change into another rock. Normally that is pressure and heat will create that. Okay, and today we don't have to look at the rock cycle. Okay, so class, what I want you to do is do this activity, which is you have to go and find a website, or if you want to watch my video again, you can do that, because I give you the link in your group. And then you have to write a little summary about the three, which is in your book, which is on page 156. Because if you just read the stuff from the textbook, maybe you won't learn it very well. But if you can make your own summary and you find your own information, I know you will learn much better. Okay, class, but before that, I think we can take a break for maybe like 10-15 minutes. After the break, you can work on your summary, and some students who did not do the worksheets, the previous worksheets, you can do it. Yeah. So like these ones. So some students who have not done this can do this today. You can finish it. Yeah. Okay, but first we can have a break. And then when we come back, we can finish it. Okay.